Yes, let's consider a continuation from what we had before. We managed to look into the bend breaks and the block separately. We had these separated. Now we are having these combined together, bend and what? And block breaks. So if we are to use the information that we had before, we are going to see that for the bend and block, it is now a combination of the two. They are now combined together. What we had in terms of the calculations before still remains the same. It is only going to be a difference in terms of the calculations when you are to consider what is referred to as the band tension ratios. But otherwise, you're going to see, guys, that it is just one and the same as what we had before. So I'm not going to waste your time. I just want us to consider just one or few things here. The bend and block breaks, if we are to consider this, a modification of the bend break is shown in Fig 2.6, which is here in Fig 2.6. All right, this is what we have. Considering this, what we are going to have is that the flexible steel bend has a number of wood blocks. It has a number of what? Of wood blocks and fixed to inside surface. And the friction of the blocks on the drum surface provides the braking action. So they are wooden blocks. The wooden blocks in this case, all right, if you are to consider this section, all right, this. So you'll be having the blocks, and in between there is a space that is in between. If you are to consider here, this part, this part, this part, it is what? The spacing, the space that is in between the blocks. So if you're to consider properly, let's say for these blocks, we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. So we say n is equal to 10 for the number of wooden blocks. For 10 blocks, you're going to notice that the spaces, these ones that are in white, the spaces that we have must be equal to 9. It's one less than the number of the blocks. So if you consider the space here, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. That is the spaces that we have. There will be 9 where the number of blocks they are what? They are 10. So you must be very careful on this condition, especially where it is mentioned. We have got these blocks that are evenly spread, and also the space is like this. Yes, some other examination concept, they don't consider some other statements which are important. So you just assume as if the number that you're given of the blocks covers also the spaces inside. So this must be considered, the space and the number of what? The number of blocks. So you're going to see the effect on the number of blocks later on, but each block that you see is going to subtend an angle to theta, which is included, which is called the included angle. So it is going to subtend as this one goes to the center. The angle that is being created is what? Is 2 theta. So they will be like this to the what? to the center like that. So it's gonna depend now, the spaces that you are given, if they have the same width as the number of blocks, as the block that you're given. Like let's say they have got the same width. Let's say this width here is what? Is the same. It means that we can have the angle 2 theta, because this 2 theta that we have is going to be for each. This one will also be 2 theta. This one will also be 2 theta. So these are the sections that are going to the what? To the center. So at the end of the day, where they are here at the center, the angle that is created, the whole of this angle here that is created, is referred to as theta. Remember, here we are talking about the contact angle, not the theta from here to say the angle 2 theta. No, the contact angle. So let me just write here. It'll be our contact angle. Remember, before we said it is the angle that is found in between what? Where we have got the bends. So this, according to this one, this part is going to the what? To the pivot. So it's a bend that we have. And here to the tangent of the drum, we also have another bend. So they will depend in terms of their tensions now to say this is going to be T1, this is going to be T2. It depends with the rotation of the drum. Remember, T1 and T2 concept according to the rotation of the what? The drum. All right. If we are to consider a clockwise rotation of the drum, it means we move from T1 going to T2. I talked about this before. So it means this will be your T1, this will be your T2. T1 will be on the right side, T2 will be on the left side. If it was an anti-clockwise rotation, it means we are moving from T1 going to T2. So that's T1. This is what? T2. So T1 will be on the left. So this will be our T1, and T2 will be on the right. So that part of the bends is actually affected. The tensions, they are affected according to what? The rotation of the drum. We're gonna look into that one later on. We are going to look into that one later on. So here, if we are to understand this about the contact angle, guys, we can simply say the number of blocks combined with the spaces together here, if they are of equal width, is this is here is what is equal the width. It means we can find the included angle, this one, 2 theta. Included angle, guys. Me, I'm a mathematician, you see. I have abandoned the theory. Now I'm into what matters, into mathematics. Anyways, you understand me very soon. So if you are to calculate the included angle now, it means it is going to be the contact angle, because it is these angles that we have are being taken from the contact angle. They are parts of what? Of the contact angle. So we must have that contact angle, the whole of it. Contact angle over what? This is the important section now, because it depends with the given information there. Like I was saying, some exam concept, they just assume when they give you the number of blocks, they assume like they are including also the spaces there. But in an actual sense, we must separate the blocks and the spaces to know how many blocks do we have. We add them to the spaces. So in our case, there are 10 blocks here. Remember, these are our blocks, the wooden blocks. There are 10 and the spaces is 9. You're going to add 10 plus 9, which is what? 19. There are 19 equal parts from the contact angle. So that 19, it is a sum of what? The blocks that we are given, which is the number of blocks. Number of what? Of blocks plus the number of spaces. Number of what? Spaces that you're given. The ones that are in between the blocks. How many spaces do we have there? So under exam condition, like I said before, you must read properly the question and understand. We are going to look into questions that are giving this into a separate concept. Say these are the blocks and there is a space in between. But the blocks that we have and that space, they all share what? The contact angle. They are all taken from the contact angle. So if they are of equal width, we must divide by those combined together, the blocks and what the spaces. This is the concept. All right, let's go back here. We're going to talk about this in our next class. Let's go back to our theory as we have got here. Each block subtends a short arc 2 theta on the what? On the drum. That is our included angle. Then the ends of the bend are attached to a brake lever so that the movement of the brake lever tightens the band around the what? The drum to provide the braking action. Thus, the brake can also have an arrangement where one end of the bend, one could be attached to where? To the fulcrum. One end of the bend here could be attached to the fulcrum. And the other one to the other part of what? Of the lever there at the where we have the end of the lever. So to the tangent, it's a bend that we have. So one will be on the fulcrum. So this is the condition of Fig 2.6, all right? So that is what we are having there. It can be attached to the fulcrum and the other side a distance away from the fulcrum, which is this one. A distance away from what? From the fulcrum. So that's what we have on Fig 2.6, which is different from Fig 2.7. As we can see, one bend is attached not direct to the fulcrum, but a distance from that. The same with this one, it is attached a distance from what? From the fulcrum. None is going straight here to the what? To the fulcrum. None of the bends. It can be a condition like that is what we have on Fig 2.7. So this is what they are saying that or both bends could be attached to the lever at a distance away from the fulcrum, as we have it on Fig 2.7. So you must note that all, like I said before, the calculations are similar to normal bend brakes. All calculations. The only difference is the formula for the bend tension ratio. That is where we are going to differ. Only there. The rest you use as you had before. The formulas, you apply them as you had before. So we are going to look into that one, like I said, looking into examples to see how exactly here, what is happening there, and you see that actually nothing. All right, another statement that you must also consider when working with the bend and block brakes is that the friction between the blocks and the drum provides the braking action. So the friction between, so this is the friction between the blocks and the drum. So it is the blocks and what? And the drum provides the braking. It provides a braking action, comes to rest when there is a braking until it comes to rest. So that is provides the braking action, which causes the drum to slow or stop as it is braking. So this causes, so which causes the drum to slow or stop. All right, we once referred to this before, working with what? A retardation, a deceleration. The drum will come to a stop where the final speed will be at 0. And that's another thing to be considered when you're working with calculations. So we said all the other formulas are the same except for the formula for the what? Bend tension ratio. So it follows that we can calculate that one. All right. So let us just consider as part of your calculations. All right. So as we are to consider our calculations here, we can have that bend tension ratios. One, bend tension ratios. All right. So actually, like we can have, maybe they can ask you for one. Let me just consider that one to say they can ask bend tension ratios for one block. For one block, let's say for one block, like a single block. Remember, guys, tension ratio is always T1 over T2. You were used to T1 over T2 is equal to e to the exponent of micro. No, we are used to that. But this is now considered different. So it follows that T1 over T2 is equal to, so this is 1 plus the coefficient of friction times the tan of theta. So take note, this is not 2 theta, it's theta. So also you must be very careful for that one because some other textbooks, they ignore that one and use it as 2 theta. They will be assuming that it is taken as a half angle already. But guys, if we are saying this angle that is subtended is 2 theta, so to find theta, you must divide by 2. You don't use as it is. So theta represents a half angle, this theta here. That's a half angle. All right, so there we know, guys, the coefficient of what? Of friction. So this is it. If it is one block considered, because it can be considered for a number of blocks. That's for any blocks. Are they 10 of them? Are they 12 of them? For any number of blocks, it follows that T1 over T2 is equal to 1 plus this as it was before, but you raise everything to the exponent of what? The number of blocks now. So this has to be raised to the exponent n, the number of blocks. That is what we have now. where theta is what? A half angle. So theta is half the angle subtended by each block. Half of that. That's why it's called what? A half angle. 2 theta is the included angle. So like I said, other textbooks, they take 2 theta as what? As theta. They use just that 2 theta as what? As theta, which is based on their conversion. But in a normal calculation, do this. When you're given 2 theta is what we have for the angle subtended by each block. Then on this formula, theta is the half angle. You must divide that 2 theta by what? By 2. So the 2 theta here, that is the angle subtended now by each block. That's our included angle. So like I said, if we have equal number, if we have got equal width for the space and the blocks here, it means it is 2 theta, 2 theta, 2 theta throughout. So to find its value from the contact angle, consider everything that is what? That is available on the diagram. Just like that. So do as much questions as you can using this information and application of moments. We are going to look into that one in the next class. I think for now, that is it that you're going to have. The rest of the formulas, guys, they are the same, considering the torque, finding of the torque, power, this and that. All right. The torque that is transmitted at the brake drum shaft. Remember, the torque is equal to T1 minus T2 times the radius of what? Of the drum. So we can even make T1 minus T2 the subject, because it is mostly used, especially when calculating T1 and T2. You have a ratio here. Then you can form another equation for T1 minus T2, which simply divide by what? Divide by R. So it's going to be the torque over what? Over the radius. Very, very important here for our calculations later on. Calculation of the power, still one and the same thing. Power absorbed by the brake. 2 pi nt over 60. So therefore, the torque can be calculated as what? 60 times the power over what? 2 pi n. It's another thing. So as we can see, it is a matter of applying the formulas. The rest is the same. So we'll see that one in the next class.